Okay, this video is on what's so special about 25 reps. We're talking about weightlifting here. So if I lift this thing up and put it down 25 times, what's so special about 25? It seems sort of arbitrary, but it's not just that you stop at 25, it's that you couldn't have done any more. You have no reps left over. So I'm going to describe a mathematical model for how you trade reps and weight. So if I want to do one more rep, I'm going to have to decrease the weight by 4%. And in this case, we're talking about where you lift it as many times as you possibly can and you couldn't do another one. That's the scenario we're talking about, trading weight for reps. So every time you want to do one more rep, you're going to have to decrease the weight by 4%. So if you have a 1 rep max and you decrease it by 4%, then you'll be able to do it 2 times. So if we look at how that looks, say this axis is the number of reps and this is the percent of your 1 rep max, and it just kind of decays away by 4%. So this is an exponential decay where the base is 0.96. So then what happens is if you consider the total number of reps times the weight, so in the beginning when we go from 1 rep to 2 reps to 3 reps, it's pretty linear because it's just the decay is only 4% per rep, but then it keeps decaying more and more and more and more, and so there's actually a maximum that occurs at 25 reps. So if we say what is the most amount of work you can do, given this model, the maximum occurs at 25 reps. And it's a pretty broad maximum, a lot of the reps. So if we move in this direction, we'd be doing more weight for less reps. If we move in this direction, we'd be doing less weight for more reps. So all of these points are till failure. So when I say what's so special about 25 reps is that that's where the maximum occurs on this 4% decay model. And of course, the video wouldn't be right if I didn't have some calculus in there. So basically, your total work is X is the number of reps, and B is the decay constant. So 0.096 decays by 4%, so 0.096 to the power. So if you take the derivative of that and set that to 0 to solve for the maxima, you get it occurs at approximately 1 over this epsilon, where epsilon is 4%, so that gives you this 25%. So another example would be, suppose we only lost 2% of our strength for every rep. Then the maximum occurs at 50. So I'm just plotting this same curve for different models of failure. Like what if we lost 3%, 4%, or 5% per rep, and we see the maximum occurs at 1 over these percents. 1 over 2% is 50. Well, 1 over 3% is 33, and so on. So that's a cool mathematical model that has consequences that you can compute from. And suppose you want to work really, really hard. So the best thing to do if you want to give it your maximal effort is 25 reps, and the weight is so heavy that you couldn't do one more rep. Thank you very much. Here's a video of me doing 25 reps at maximal effort. So please post a video of you doing 25 reps in the comments below. Let's see how good you can do. Thank you very much. Here at the gym, we're under Aries BJJ Arena Training Center. Hopefully I can do this in one take. There's not going to be a second take. So here we go.